Hi, my name is Kang, and today I'm going to present to you on question number 2. Okay. In question number 2, there's two parts, part A and part 2, and in question part A, there's two parts also, 1 and 2. So in part 1, it says that given 18 is equal to 2 times 3 to the power of 2, write 3, 2, 4 as a product of prime factors. So first of all, what do we know about prime factors? Prime factors are prime numbers. Okay, if it itself is also a factor of another number. Okay, so how do we find the prime factors? Okay, we're going to use successive short division method. Okay. So how do we do it? We'll do this, and we'll draw this. Alright? So we'll divide by the prime numbers. Okay? So first we'll use 2. We divide by 2, and then we get 162. And again, we can divide by 2. We'll get 81. Then after 81, cannot be divided by 2 anymore, we divide by 3. We'll get 27. After 27 is divisible by another 3. Then we'll get 9. Okay, due to lack of space, I'll write it up here. So from 9, okay, it's also divisible by 3. Then we get another 3. Alright, and then 3 itself is divisible by 3. So we get 1. So when you write out in the factorization form, prime factorization form, 3, 2, 4 is equals to, how many 2s we have? 1, 2, so it's 2 times 2. How many 3s we have? 1, 2, 3, 4. So 3 times 3 times 3 times 3. Okay? So if we express it in terms of indices and power, so it's 2 to the power of 2 multiply 3 to the power of 4. So far, any questions? Okay, you'll get it? Alright, nice. So the second part of question A, it says that the HCF of two numbers is 18. The HCF, which means highest common factor of two numbers, is 18. The lowest common multiple of two numbers is 3, 2, 4. So for these two numbers, they are both greater than 20. So what are these two numbers? How do we find? Okay, so based on what we found in part 1, alright, we are going to use the prime factors to find our answer for this. Alright, so using prime factorization method, okay, we look at 3, 2, 4. Okay, 2 to the power of 2 times 3 to the power of 4. So if you expand it, it can look like 2 times 3 to the power of 2 times 2 times 3 to the power of 2. So why do we want to make it in this form? Because from the very onset, we already know 18 is equal to 2 times 3 to the power of 2. So for here, this part, we know that this is 18. Okay, times 2 times 3 to the power of 2. So this itself, 18 itself, is a common factor for the two numbers. Okay? So, due to lack of space, I'm going to write up here. 3, 2, 4 goes to 18 times 2 times 3 to the power of 2. Or we expand it times another 3. Okay? So, first number. Second number. We know that it has the factor of 18, so we write 18 down here. Okay? Next, it says that the highest common factor is 18. That means these two numbers, other than 18, they cannot have any number that is bigger than 18 already, because their highest common factor is 18. So how can we solve that issue? We can just bring it down. Okay, so this one times 2. And then we bring these two numbers down to the next number. Alright, so from here, we will get this answer from here. Okay, sorry, we're going to do this. 18 times 2, we'll get 36. 18 times 3 times another 3, we will get 162. Okay, now we have these two answers, 36 and 162. So how do we check whether these two numbers fits our criteria? Okay, by using the successive short division. Okay, we are going to use that method and find out. So we draw the ladder, 36, 162. First, we divide by 2, then we get 18, and then 81. After that, 2 cannot be used, 3. This one will get 6, and this one will get 27. Then after that, 6 and 27 is divisible by 3. Then we get 2 and 9. Okay, so from here, we cannot divide anymore. We know that these are the common prime numbers among these two. So how much is it? So let's just do the sum. 2 times 3 times 3, which I'll get 18. Alright? So it fulfills the first criteria. What about the second one? So from here, why don't we continue with our successive short division until both sides are equal to 1. So what we do from here, this one we first divide by 2, so this one will become 1. This one still a 9. Alright? Then 9, 3, then will be 3. So this is 1. And then this 3 again, and then 1. So both sides are 1. By multiplying all the numbers together, we will get our LCM, the lowest common common multiple. So 2 times 3 times 3 times 2 times 3 times 3 will give us 324. So we fulfill the second condition. And the last one, it says both numbers must be greater than 20. So I have 36, I have 162. So it is definitely greater than 20. So these two numbers are my answer for part 2 of A. Alright? Okay, any questions? So I have a question right now. So why can't, okay, let me erase this. Why can't one of the factors be one of the three be on the first number? Okay? Why is it not? Why not? One of it is like over here and not here. Okay? Why? If we do that, we'll find out that actually the highest common factor, if a 3 is up here, will be the highest common factor for these two numbers will be 18 times 3. Okay, that will give me 54. So instead of 18 being the highest common factor, in this case, the highest common factor for these two numbers will be 54. Understand? So if you have any if you don't have any questions, let's move on to part B. Okay, due to lack of space, I'm going to erase off. Alright? Okay, I'm going to put the answer here. First number 36. Second number 162. Alright, so now we look at part B of the question. It says given 10976 as a prime number, prime factors of 2 to the power of 5 times 7 to the power of 3. And then 10976 divided by P over Q, where P and Q, they are prime numbers. And this number here is a factor of 10976. There is an integer and also has a power of 4. Okay, when we talk about integer, it doesn't mean that it has to be a prime number. It can be a composite number that is a product of two prime numbers also. So let's deduce, okay? From the prime factorization, we can tell the prime numbers here, P and Q, they are either one is 2 or the other one is 7. So they are one of these numbers. Okay? Who is who? We don't know yet. And this one, this number here is an integer. That means it must be a product of 2 and 7. Okay? So, because it cannot be anything else from a prime, we can tell from a prime factorization. Okay, so it's 2 and 7. Alright? So let's solve this question to find P and Q. Okay, I'm going to write this thing down here. Okay, 10976 divided by P over Q is equals to 2 times 7 to the power of 4. Alright, so I'm going to put the prime factorization form here. To the power of 5 multiply 7 to the power of 3. Okay, we learned that when we divide a fraction, we can flip the fraction over and change the sign to times. So it's Q over P. Okay, and then continue. We open out the bracket. So 2 to the power of 4 multiply 7 to the power of 4. So far clear? Okay, next, what do we want to do? Let's move this over to here, and let's move the unknowns over to the other side. So if I rewrite, it will look like this: 2 to the power of 5 multiply 7 to the power of 3 over 2 to the power of 4 multiply 7 to the power of 4, which will give me P over Q. Okay, let's just remove all the common terms and do the division. Okay, 2 to the power of 5 over 2 to the power of 4, I'll get only a 2. 7 to the power of 3 over 7 to the power of 4, I will have. Okay, so let's continue on this side of the bank, on this side of the board. So I have 2 over 7 is equal to P over Q. So we do by comparison, we can say that P is equal to 2 and Q is equal to 7. Okay, so far any questions? Okay. So next, how do we ensure that this is correct? Let's plug this whole thing back into here. Okay, and from here we know that is equals to this line over here. Okay, I'm going to write this line down here. To the power of 5 multiply 7 to the power of 3 is, then multiply 7 over 2. I will get, so this one can cancel off, put a 4 here, this one is a 1 and I add to this one. Okay, so I'll have to the power of 4 times 7 to the power of 4. If I take out the power, I have 2 times 7 to the power of 4. 2 times 7, eventually I'll get 14 to the power of 4. Alright, so far any questions? Clear about this? Okay, thank you so much.